I'm a lecturer in architecture here at Montpellier University, and I'm going to introduce you to the first speaker today, is Yasser from the University of Leicester. So I'll let him introduce himself, and we look forward to your talk.
Good morning, everyone. So my name is Yasser. I'm a senior lecturer at the university. I specialize in sustainability engineering, so I've worked on sustainable insulation from agricultural waste, building simulation for different parts of the world, informal settlements, creating business homes in the UK, etc. I also teach architectural design, advanced design, digital application, etc. I like to think I'm a jack of all trades, but I think the thing I like to focus on most is sustainable building engineering or sustainable architecture, synonymously. So without further ado, I'll get started. So today's talk is BIM and LCA, lifecycle analysis between the status quo and the future. And we'll get to what lifecycle analysis is in a second. But there are two codes that I like to follow that really kind of shape how I think when it comes to BIM and sustainability. Those who walk the earth gently, humbly, and when the ignorant harassers address them, they say peace, and do not obey the command of the opulent ones, those who spread corruption in the land, and do not reform. The focus is on the word of reform here, and in the land, and walk on the earth humbly. What is life cycle analysis? Just a show of hands. Who's heard of LCA before and actually knows the definition? Right, my point exactly. It's not something that's very popular in the status quo. LCA is a method of measuring the environmental impact of a product or service throughout its entire life cycle. From raw materials to disposal, it helps us understand how our choices affect the environment and how we can reduce our negative impacts. What does that mean? Production stage. What is the embedded carbon of every single process during the extraction of those resources from the ground up? Construction stage. How much carbon is embedded for you to actually build the product? What goes into building that product, transporting it, using different mechanisms, etc., melting it, boiling it, etc. The use stage, during its life cycle, by using that material, instead of using another one, what kind of effect do you have in your building? Are you using more heating or less heating, for example? As I'm specialized in insulation, if I use one insulation over the other, what is the embedded carbon or life cycle stage of that material throughout its life cycle in the building? And end of life stage, when we get rid of it, where does it go? Where does it land? Now, I use the word carbon a lot, not because I'm very fond of the word carbon, but because it's a buzzword, and sometimes the industry really does forget about methane and the other hazardous chemicals or even gases that are emitted from construction or from product design. So let's just stick to carbon, but of course you have to understand there are much more levels than just carbon. In a building life cycle, I just said we had the production stage, the construction, then use, and end of life. There are several stages within those stages. I won't go through them all, but you will see that the reoccurring pattern at each stage is usually transportation. And just a tip, transportation is usually the biggest problem when it comes to life cycle assessment as a platform problem. So every single product has a problem of transportation, but it is not the main problem. In life cycle analysis, there are three main terms that you really have to know. I won't get too deep into them today, but just for your general knowledge. Cradle to cradle is basically a circular approach that aims to design products that can be reused, recycled, or composted. So something you either put into the ground and you won't worry what will happen afterwards, or you can recycle it, or you can biodegrade it, or you can reuse it. Cradle to grave is a linear approach that covers the entire life cycle of a product, from raw material to extraction and final disposal. So you know exactly where it's going to go at the end of this life stage. But it's not going to be reused, maybe it's not really compostable, but when it goes into the ground, maybe it won't have that big of an effect on the environment. And cradle to gate is a partial approach that only assesses the impacts of a product until it leaves the factory grade. Newsflash for you. Most companies do not even provide a cradle to gate approach. They don't even know how much carbon is embedded in that product from the point of extraction from the ground up until it reaches your door via delivery courier service. Most companies. So this begs the question, what is the importance of LCA in BIM?
Then we talk about the amount of materials that we use. We talk about integrating different disciplines together. We talk about multidisciplinary approaches to design, interdisciplinary approaches to design. What does LCA have to do with BIM? And this is what brings you to the status quo of LCA tools within BIM. If you're going to try to develop a life cycle analysis of your building, you have more or less 3 tools you can use. There are so many other tools, including Cyma Pro. But if we're talking about Revit, and we're talking about integrating it with a BIM-based software, we either have eLCA, Tally, or one-click LCA. Before I move on, they all have their pluses and their minuses. eLCA is not really integrated with Revit. You have to use it independently. Revit uses Tally, and one-click LCA can be used with Revit, ArchiCAD, Simple BIM, or it can be used independently. So you can put in the numbers and you can calculate everything without the need of a BIM software in the first place. Now, what is the problem or advantage of using each of those softwares? By the way, just for my information, who's used one of these softwares before? So 5, that's wonderful. eLCA has a problem. Mass balance creation is time consuming due to user interface and user experience design. Also, it's data retrieval. It has a very slow data retrieval system, and it's not that complicated. So you have to put in all the data yourself. Advantages, it provides a basis for LCA calculations. Tally also has a problem. Inaccuracies in models which impact LCA quality significantly. It offers semi-automated approach for calculation. So basically what you put in BIM, or what you put in your Revit model is what you're gonna get out from Tally. But the problem is any inaccuracy within your BIM model will show immediately in your LCA analysis. So even if you have the data there, if there's any inaccuracy with the model, it'll show. And one-click LCA. The problem is the result quality is tied too much to the model or to the data accuracy. And I'll come to that in a second. So if we were to look at what is the main common problem, from what I've just said, what do you guys think the main common problem is when it comes to using these different softwares, regardless of which one you choose? What is the word that has come up over and over and over again? You can say something, it's fine. I won't be offended. Okay.
Inaccuracy, variations in results.
Variations in results, which are based on variations in data. Data is the main problem here. But I'll go a step further before the data. With my personal case study with BIM or with LCA analysis, I was trying to create, and this is in my postdoctoral research, I was trying to create an insulation panel for grade 2 listed homes. And the way to do that is you have to refurbish from the inside, not from the outside, because you're trying to keep those elevations intact. And so I was trying to develop an insulation panel that was 100% compostable, made from agricultural waste fibers. In my case, it was wheat straw. As slim as possible, and refurbish it on the inside, have the same U value as foam. Because when you use foam, you're gonna have at least 30 to 50 centimeters of insulation on the inside when you're refurbishing your home. That's a lot of interior real estate to waste for insulation. But if you have a panel that's 5 centimeters thick, it's compostable, you use much less interior real estate, and it's great for the environment, and it's cheap, and it's local, and you create a life cycle, a circular economy with farmers, because you get to use that wheat straw, instead of creating foam, which is created from nothing. It went well. The panel was great. I was able to create a panel that was small size, industry sized. I was able to test it for mechanical strength according to the British standard industry specifications. I was able to test it for U values. I was even able to test it for moisture levels and for biodegradability and for molding as well. It all went well until it came to the LCA analysis. So I tried to go amateur and I tried to go pro. I used the free version to see what's going to happen. And just to give you an example, my panel has a few materials in it, but one of 3 of the materials that are in that panel is wheat straw, water, and potato starch. To get the data for wheat straw, I could only use wheat straw from Germany. That's number 1. And I'm in the UK. And my wheat straw is based from Nottingham. I bought it from a farm in Nottingham. That data is not there. The potato starch was sourced from France. And the water was sourced from North Italy. This is the free version. So we went a step higher, we applied for funding, we got funding for the software, we bought the whole license, and now we have the paid version. So I wanted to get wheat straw. The only wheat straw that they source was somewhere north of England, I can't remember which borough it was, but there was no other wheat straw to be sourced anywhere else in England. So the data I had was incorrect. The transportation, how much water required, the soil it grew in, all of that was incorrect. The potato starch was still sourced from, this time it was Germany, so potato potato. And the water, I could not even source how the water is treated so it can come to the tap water in the Midlands. And so basically, if I wanted to do an LCA analysis, I could. If I wanted to just click the buttons, I could, but it would be a lie. And so I couldn't create an LCA analysis for my panel. And so I couldn't make the claim that my panel, from a carbon footprint standpoint, is better than a foam panel. It's better than the conventional insulation panels you find in the market. I couldn't make that argument. In theory, it is better. Practically, I don't have the proof. And that's how I set out on a paper with my supervisor to actually compare between different types of insulation panels, conventional ones and sustainable ones, such as hemp insulation, coconut insulation, cork wood, mycelium, and also foam, mineral wool, plastic, etc., and see where the discrepancies are. And to cut the story short, companies or mainstream companies, they do have LC analysis for their insulation panels because they can afford to do it. They can afford to get the data. Whether the data is right or wrong, that's another story, but they can afford to do it. Whilst newcomers to the market with their sustainable insulation panels, they can't afford to do that. So they can never stand to Big Brother and say, hey, your LCA analysis is wrong, or we have a better LCA analysis, and so our product is more sustainable. The future of LCA in BIM, or life cycle analysis in BIM. To me, it's a question of design and data at the same time. I want to turn to Professor Noriaki Kano. He was a professor in the 1980s, and he is the father of modern user experience design theory. So what does this theory involve? Any product in the world, any software in the world, for it to be successful, you need three major aspects to be fulfilled. You need your project or your software to be hygienic. It needs to be linear. It needs to be delightful. Now, what does that mean? Hygienic is basically a function within your product. If it is not there, you will simply not use it. If it is there, you will not be happy. You expect it to be there. You expect a pen to write. If a pen writes, you're not going to clap because the pen writes. So there's nothing cool about it if it does what it has to do. Believe it or not, some products do not have a hygienic function. And that is why with time they fail in the market, or people switch to the next product the minute a new product appears. And I'll give examples in a while. A linear function. A linear function is something you would like the product to do. It's not inherently basic to the product. It's not inherent to the product. But if it's there, you would want it to do it properly. And I'll also give an example about that. And the third is a delightful component. It's something you don't even expect it to be there. But if it's there, it's a nice to have. You don't have to have it, but it's nice to have. A perfect example is your iPhone. If your iPhone gives you crisp quality calls, allows you to put people on hold, have a conference call, have a video call, you will not be surprised. You expect your iPhone to do that. That's a basic function of a phone. If it has a good camera quality, that's a linear function. Some people switch from Android to Apple just because of the camera. I did. It wasn't something that was basic to me, but I wanted a good camera, so I switched. And the delightful function is the nice airdrop function that we have, especially now when you tap the phones together and they give you that nice bubble sci-fi move. That's a nice to have. If you don't have airdrop, it's not the end of the world. You can always send things via WhatsApp or Bluetooth. So what does that have to do with LCA? From my humble experience with LCA, I think it's a problem of design before anything else. We don't have enough people using LCA analysis because the design does not make it attractive to use. If any of you have ever tried to use the software, and I think those of you who use the software will agree with me, it is extremely un-user-friendly. It is very hard to use, and when it is easy to use, it's still extremely complicated. Some people even turn to Excel sheets as a substitute to using the actual software, and they get the same results and sometimes even better. So when you have to use an Excel sheet to bypass a product that's been developed for the past 5-6 years, that says something about the user interface and the experience. So it needs to be linear. It needs to provide you with the basic function you need, but also it needs to have the proper data. If you don't have the proper data, you will not be able to design anything. And this is what I'm going to speak about before I move on to the functional part. Imagine you're trying to buy a food produce or product, and you have no idea what's in it, no idea about the nutrition, how much sugar is in it, how much protein is in it. That's exactly how we're designing our buildings. We have no idea where this casement came from, where it's going to go, how much carbon is emitting, how much energy is it sucking out of the building. We have no idea what we're using in our buildings. So the data is still not there. Hygienic. You have to be able to use the functions that you need. If you need graphs, you need to see them. If you need a contrast of materials, you need to see them. If you need to see certain things in certain ways, hierarchies or similarities between products, you also need to see those. Those are hygienic functions. And delightful. The use of AI now is almost in everything. So if we're able to get AI to give us suggestions on what materials to use in our life cycle analysis, that would be great. Suggestions, that would be great. Fees of the certain products that we're using, or drawings. Permit advice, planning and strategy, or even details on how to use those products in a more sustainable way. I actually have a friend of mine who developed an AI tool called Conix AI, CONIX.ai. It's a platform where you can just put in your plot of land, which country you're in, what you're trying to design. It'll give you all the plans and sections and elevations you need in a second. So if we have that within LCA analysis, that would really give us a delightful feature of how to use materials in a more sustainable manner. To conclude, we have 4 minor issues, in my opinion, and 1 major issue that would prevent LCA analysis from developing further. The first is data integration. Nobody doesn't have an address, except if you're homeless, God forbid. Nobody doesn't have a phone number. Nobody doesn't have a name. No product should go into our buildings except that we know where does it come from, what's in it, what will it take to dispose of it, how should we dispose of it, how has the manufacturer designed it to be disposable. There needs to be a push from us as architects and engineers, and in academia especially, for manufacturers to actually do this. Which brings me to my second point, manufacturers. Long story short, manufacturers don't care. All they care about is their economy. This is the neoliberal society we live in. You are the buck you make. If you want to change that paradigm, you're going to have to provide a different paradigm for manufacturers to be in. If you don't provide that data, we're not going to buy the product. It's as simple as that. From stadiums to skyscrapers to whatever project you're working on, you need to demand that data to be able to work with it properly. Industry-wide adoption and lobbying. Business to business, business to customer. It's all about providing the right field for everyone to understand that this is something that is integral to what you're asking for. I bought a scarf the other day. Beautiful scarf overseas. It had no information. I didn't know if it was wool, if it was cotton, if it was polyester, if it had all 3 together. I had no idea. I was going mad. And that's just a scarf. We literally do this every day with millions of pounds, and we have no idea what are these things made of. Do they have slavery in them, modern slavery in them? We have no idea. And so it's about more of a movement than it is just manufacturer or designer. BIM or LCA tools in software development, that needs to be at the core. We need to be able to design better. In architecture, I used to teach a class about urban design, but also how to design a software on an app, on a mobile, to be able to bring people closer to that social space, how to be able to book social spaces in a different way. That's the age we live in. If you're not able to provide user experience or user interface, your product or your design is not going to be successful. You need to create a software that's successful. How much energy do you put into Grasshopper for it to be this seamless, color coding and strings and tags and labels? How much effort do we put into Rhino for it to have all of these icons? And if you don't know the icons, you can just tap in the order. LCA tools are nowhere near as user-friendly as those softwares. And those softwares only give us great, but sometimes frivolous forms. It's all about the form. When we're asking about sustainability, when we're trying to target sustainability, we don't find that. The software is suboptimal, that we use Excel instead of actually using the software. And finally, our priorities. I think one of the main issues in all of this is that we, as a community, I speak about myself before anyone else, we did not provide enough of a push. We did not show enough of an intention to change how we design and what priorities do we have in our design process for manufacturers, for designers, for software developers to say, yes, we're going to put an effort into providing a better LCA analysis or to providing that data freely available. I'm on a mission now to be able to calculate the LCA analysis of my panel. I'm telling you, it's a very difficult mission to be able to calculate what cars are being used and how much gas was put in and how much time was needed to grow that wheat. It's a very difficult process. This should not be something that every person has to do. And so I hope with time, as we use BIM more throughout our careers, we're able to see the importance of having a life cycle analysis and being able to develop that through our careers and also contribute to it. What you ask for from your manufacturer will change everything. What you do in your own practice will change, and in your own research, it can change everything. Thank you.
Thank you very much, Yasser. That was very, very insightful, and also you picked up on some very interesting concerns that I think brings them to the forefront for all of us to think about. Do you have any questions for Yasser here? Before we move on. Yes.
There's new legislation coming up next year, CSRD, which requires small companies with a turnover of more than 50 million to do environmental reporting, so non-financial reporting. So that doesn't affect a lot of companies. They have to comment on the impact of their products and also the impact of the environmental crisis on their business as well. So even their suppliers will have to start reporting this data as well. So if it's solvently, it just exaggerates the problem. The lack of decent information and the accuracies within that LCA and things aren't really discussed. The legislation's coming in, but the software isn't fit for purpose. No doubt in time, because of the questions that happen, but people should be aware that companies have to report this data as accurately as they can.
Yes.
So height of those medium-sized to large companies next year within Europe and exporting.
Thank you for that. I mean, yes, it does exaggerate or it does put the problem on the spot, but I think we all need to do that because the problem is not even there most of the time when you speak to someone about LCA. And rightfully so, you don't know what you're talking about. And I don't mean to disintegrate the certifications we have, but we have many certifications. As an example, be certified. It's great, I really respect it. But many times it's used as a greenwashing strategy. And so what you're saying is it's a great step for us to go forward. Maybe that will be a catalyst for some sort of software becoming more popular and hopefully.
And ultimately, the global warming potential, which is one of the outputs of the LCA, if we don't get that right, nothing else matters, even though in the regenerative economy we have to consider everything, but GWP, the CO2 equivalent score is critically the most important thing. We have to consider everything else.
Thank you. So, if nobody has any other questions, I'll let my colleague Tarek take a stand.
Any other questions or comments?
Actually, I have
Yeah.
it's regarding the AI, similar along the same line. You've mentioned OpenAI, right, which is something that is still being worked on. Some countries, of course, they've started to implement this, which goes into the whole policy aspects and everything of BIM. Would you then say for the LCA, right, because it's quite more sophisticated compared to other elements of BIM, maybe architecture and so forth. How do you see that developing in terms of the push or the pull factor alongside with the AI technology and perhaps controlling that in the sense of having standards? You see the way BIM has standards, we can follow these rules. Now in terms of using or creating, should I say, creating an AI standard kind of thing to enable that growth for the LCA. What are some of the ideas or things that you perhaps follow, what directions?
I think the thing about AI is that because it's so fast and because there's a lot of internal learning involved, a lot of people are very attracted to it because of the things it can do, which would save them a lot of time. So I wouldn't count on AI as a denominator or as a main factor in where the LCA analysis should go or how it should operate. But I think it would really help people to see, once you integrate AI with a proper LCA analysis, where the right data is there, the right model is there, it can create a seamless transfer to other parts of the project, permits or planning or whatever it may be. And I think that's something that's very attractive now, that how you can connect different things using AI in a very good way. Concept modeling in architecture, just create 20 variations in 2 minutes. So I think that's it. But I don't think it can provide the right information because there are lots of nuances. What car did you use from A to B? And what's the weight on the car? Was it rainy? Was it not rainy on the day? Was the journal? All of these things will take. I don't think AI can develop it that quickly. These nuances we have to put in, I think, ourselves. Thank you. Thank you.
Thank you.